Welcome all, and thank you for attending today's session. My name is Gaurav Manglik. I am CEO and co-founder of Clicker Technologies. So we are all here at this magnificent event for a single reason. Cloud adoption is growing at a rate faster than ever before. Organizations are placing more and more application workloads on cloud infrastructures. While that is happening, what we are seeing is that cloud services, the infrastructure, is also maturing very rapidly. Just over the past couple of days, we have seen some awesome announcements from Amazon Web Services. Today, more than ever before, companies have more options, more choices available from cloud services and cloud providers. These growing degrees of freedom are paving the way for increased cloud adoption for the enterprise. This flexibility is awesome. While this flexibility is great, it's also coming along with a lot of complexity when it comes to cloud management. The theme of today's discussion is how a traditional approach to automating application deployments, automating application management on cloud infrastructures is no longer scalable, and how companies need to take a very different application-focused, model-based approach to cloud computing. Now, this presentation today is not a sales presentation, it's not a marketing presentation on Clicker Technologies, but it's a theme that we are seeing across the board where companies are looking for a more and more simpler, abstracted way to onboarding and managing applications on clouds. Several such solutions are available in the marketplace around these. Clicker is one of those. So after my presentation today, I'll be also giving a very short demo of how Clicker is providing application-based cloud management. Towards the end of my presentation, we'll have a very short Q&A, and I'll be happy to take any questions from the audience. So a good starting point to look at automation is by starting with just traditional data centers. So in the old world, where companies were running legacy applications, the old world was organized around infrastructure and around applications. Your infrastructure was compute, storage, and networking, and then you were running the likes of SAP, SharePoint, Java Web Applications on those infrastructures. For every application and for every infrastructure configuration, and changes either in application or infrastructure, one had to manually configure, manually tune, and manually manage those applications and infrastructures. Often, as you all know, there would be two different teams, an infrastructure team and an application team. The infrastructure team would be tasked with managing the infrastructure, and the application team would be responsible of maintaining those applications on those infrastructure environments. Typically, the infrastructure came before the application, and it was the application team's responsibility to make sure the application conforms with the infrastructure that those applications are going to run on. The next stage in the evolution of data centers was software-defined data center. With the advent of virtualization not just around compute, but also storage and networking, essentially we had the advance of software-defined data centers, where through programmatic API controls, one can spin up compute, storage, networking, and configure it. This started with on-premise private data centers, private clouds, if you will. But if you look at public clouds like Amazon Web Services, they're essentially an extension of a software-defined data center where you can programmatically, for example, on an Amazon, get compute such as EC2 instances, configure storage through EBS and S3, and also configure the network on such environments. This resulted in better efficiencies, better automation around infrastructure. However, what this did not change was the application management. The application workflows, the application scripts, the application management was still disconnected from the infrastructure. This is how cloud started. This is what companies have been doing in the first phase of cloud computing. What we are seeing today is that the number of workloads that are growing on clouds is tremendous. According to this study from Cisco, the number of workloads, applications running on private and public clouds will double in the next 5 years. There'll be a total of 200 million workloads running across different cloud environments, which represent about an average of 5,000 to 10,000 applications per every large global 2,000 corporation. While the number of workloads on clouds is increasing, what we are also seeing is that those workloads are not very static workloads. Today's workloads are Generation 3 web applications, highly scalable, going through an agile life cycle where code is being rapidly developed and being pushed out. In fact, the top performing companies are pushing out code faster. And those applications are higher quality, higher performing. So there's a great increase in the number of applications. There's a great increase in the number of times those deployments are getting pushed out. The third aspect that's happening is, while the number of applications is increasing, the number of infrastructure choices, what I call execution venues, where you can run these applications, is also growing very fast. That number, 54,872, represents the number of ways you can actually run a 3-tier application if you were to explore 38 different instance types on Amazon alone. That's a tremendous amount of choice. And our friends from Amazon Web Services tell us that's actually a pretty low number. If you look at configurations such as spot instances, if you look at different storage type options available on Amazon, the number of actual configurations to deploy a 3-tier application can be even much larger. It can actually run into the millions. How do you know today what is the most optimal, the best venue to run my application? Here are some really simple examples that we did at Clicker. So let's take a very simple application like Pet Clinic, which is a 3-tier application. Now, the different tiers of this application, the web tier, the load balancer, and then the database can be placed on different instance types on Amazon. Today, right-sizing an Amazon environment is often problematic. Just by looking at the instance type definitions alone, it's impossible to tell what's the most optimal configuration. Should I be running my database on a large instance or a medium instance? Is the bottleneck the app server, not the database itself? The only way to do this is to really try out all the different instance types that are available on an Amazon. What this graph is showing here is on the x-axis, you have the cost of running a 3-tier application on a per-hour basis. And on the y-axis, there's a performance criteria. The performance criteria that we have chosen here is actually an application criteria, which is the number of requests per second the Pet Clinic application can handle. As you can see, the lowest cost option, the cheapest option represented by this configuration may not be the most highly performing one. And the most expensive option here might also not be the most highly performing one. Varying the different combinations between the different tiers might give very interesting results, and the trade-offs can be very interesting. As an example, would an increase in the number of requests per second justify the cost increase? These are all choices that today an organization has to make when trying to decide how to run your applications, where to run them on a cloud infrastructure. That's for a 3-tier web application. A lot of workloads running on clouds are also batch computing workloads, high-performance computing workloads, and the same analysis applies there here. This is a different application. This is a high-performance computing application called Blender, which is used for graphics rendering. And we have done the same analysis here. The axes are actually flipped. The y-axis here is the cost. The cost in this case is not the per-hourly cost of running a web application, but because this is a batch application, it's the actual time to run a graphics rendering job in Blender. The y-axis is the performance criteria, and the performance criteria here that makes sense is the time it takes to run your graphics rendering job. Again, as you can see, the options are not obvious. What might be the highest performing instance type based on just pure compute, based on pure infrastructure options, might actually not be very cost effective. So the knee of the curve typically actually shows here what's the most price performance optimal configuration. Where am I getting the most maximum bang for the buck? That's actually on a single cloud Amazon. Today, every company also has a choice of multiple public cloud providers, different cloud services, as well as your on-premise private cloud environments. A study from NTT showed that on an average, large companies are using 4 cloud platforms. Now, this includes private cloud technologies like VMware and OpenStack as well, but that's a pretty significant challenge. The amount of choices available on a single cloud is so large. Now, if you take that across multiple cloud providers, it becomes impossible to determine what's the right option for a particular workload. So those are the 3 degrees of freedom. The 3 degrees of freedom is increasing number of applications. The number of applications companies are running is growing very fast. Those applications need to run on varied infrastructure environments. It can be a single cloud like Amazon with multiple options available, or it can be multiple cloud environments. Different applications might make sense to run on different cloud environments. Different cloud environments provide different price, different performance, different security, different SLAs, and those choices today have to be made. The third degree of freedom is, unlike the old world, unlike the old data center, both the applications and the cloud environments are changing very rapidly. Applications are going through an agile DevOps cycle. They're moving from a dev stage to a test to stage to production. And on the cloud side, we're also seeing tremendous amount of changes, where, as an example, Amazon will introduce new and new options such as instance types. Going back to the thesis of this presentation, in such a world where there's so many options, the number of applications is increasing, the number of cloud choices is increasing, traditional approaches to data center automation, which have required scripting or creating workflows where every application has to be hardwired to every infrastructure choice, is no longer scalable. The approach that a lot of companies are looking at is a more layered approach, where you have to start with application models, you have to look at application blueprints, and then let those blueprints drive everything underneath the application, including the infrastructure. Let's peel the layers of the onion here a little bit and see how the old approach would work. So the script that is shown here on the right, on the left-hand side, or a workflow, is how a typical 3-tier web application would be automatically deployed on a cloud like Amazon, and the kind of steps the user would have to take either manually or scripted inside a workflow. So in a typical 3-tier application today, on an Amazon Web Services environment, you have to launch EC2 instances. So for all the different tiers, for the database, for the application server, and the load balancer, you have to launch the right compute instances. This can be done manually through an Amazon console, or a user can also do this in a script calling into Amazon APIs. For each tier, there will be different storage requirements. For example, a database tier might require persistent storage, while the app server and load balancer might just need ephemeral storage. As part of that deployment workflow for the database, the right kind of storage would need to be configured. The right kind of storage, EBS volumes, would have to be mounted to the database virtual machine. That's compute and storage. Similarly, on the networking side, one would have to decide how the different tiers have to be placed into different environments, such as different VPCs. Between the different tiers, there are going to be certain firewall rule configurations that would be desirable. For example, you would want the application server tier to be able to talk to the database, but the database should not be accessible by any other service. Those network ACLs, those firewall rules would have to be configured. As an example, on Amazon, that would have to be done through security groups. For each of the tiers in the application, you would also have to install the application middlewares and the components. For example, for the database tier, you would have to install the database. For the database, you'll have to load up the database schema, the database artifacts. Similarly, for the application server, you would have to install the application server middleware. On that middleware, you would have to find the database properties, such as the IP, such as the database IP, as well as the port on which the database is going to accept connections. Those will have to be configured inside the application server, and then you would have to also load up the application artifacts. The same goes on for the load balancer. Between the different tiers, you would also have to start the services. So you'll have to start the database, followed by the app server, followed by the load balancer, which would follow the dependencies in the application topology. This is the typical traditional approach that users have taken to enable applications on a cloud environment. As you can see, it's a fairly complicated approach. It requires the user to understand the application, but the user also needs to understand how the cloud environment works, how the cloud infrastructure works, and how you can call out to the cloud's SDDC layer, the software-defined data center layer, the compute and storage and networking APIs, to get the infrastructure that the application needs. Clearly, this approach is very time-consuming, very labor-intensive, but the bigger challenge is that the approach requires intermixing of infrastructure elements and application elements. So the same workflow has infrastructure aspects where you're calling out into infrastructure APIs, and then the same workflow also intermixes application deployment, application installation, and service configuration aspects. If anything changes in the infrastructure, if anything changes in the application, then one has to go and redefine, rework on the script. Sometimes changes can get really complicated. For example, for this topology, you might actually want to introduce a backend cache. You might want to run a database, maybe in a disaster recovery or a HA mode. As soon as that happens, not only does the workflow change significantly, but on the infrastructure side, you have to configure the right infrastructure elements desired by the topology in that workflow. Such an approach would not scale if one were to take thousands of applications, hundreds and thousands of different infrastructure options on a cloud, and it would slow down cloud adoption. So what we are seeing as a trend is an application model or a blueprint-based approach where a blueprint can capture the entire application topology, the service-oriented architecture, if you will, and infrastructure decisions can be disconnected from the blueprint, and infrastructure choices can be made at deployment time. A very simple way to look at this in terms of approaches is a traditional approach is a script or an orchestrator-based approach. In the traditional approach, one has to create a script for every cloud, for every cloud configuration, for every application. Not only is that script required for the first-time deployment exercise, but you also need to create and manage scripts for ongoing management exercises, such as maybe your application workload is scalable and you want to implement auto-scaling on Amazon. Or maybe your application workload needs to be patched or needs to be upgraded or integrated with your CI/CD processes, such as Jenkins. All of that requires additional scripting. Any change in the application, any change in the infrastructure, you go back to the script. A very similar approach is orchestrators. And orchestrators are typical workflow engines that are hardwired or created for particular environments, such as an on-premise virtualized infrastructure or a public cloud. The orchestrator approach is very similar to a script-based approach, except that orchestrators, often with integration with systems management technologies, are able to provide a more comprehensive lifecycle management of applications on clouds. So not only are you able to do the first-time deployment, but also able to take care of the ongoing management of your deployments on cloud environments. The approach that companies are gravitating towards is more of a model-based approach. And really, that started with PaaS platforms, platform as a service. And a PaaS is really a model-based approach where building blocks, PaaS services, load balancers, app servers, databases are available. All the infrastructure complexity is automatically taken care of behind the scenes by the PaaS service. And the user can very quickly model their application workloads using that PaaS. That's a great approach, and that's really where this started. However, the deficiency of PaaS approaches has been the kind of blueprints, the kind of models that one can create are limited to what the PaaS services can provide. So the PaaS service can only provide a certain set of database types or app service types or load balancers types, and you're limited to that particular configuration. So approaches in the market around blueprinting and templates and profiles are emerging. Amazon CloudFormation is one example of that approach. We'll be doing a short Clicker demo, and Clicker is an example of that approach as well. But essentially, what an application-defined approach lets you do is take a more layered approach to application management on clouds, where you start with the application itself. So you start with an application model. The application model can use underlying services. These services can be PaaS services available from cloud providers like an ELB, like an RDS from Amazon Web Services. Or services could also be application components that get installed on base virtual machine images on the cloud provider. So one takes that approach where you create such services as building blocks, Lego blocks, if you will, as well as make those services parameterizable, where those services can be deployed on different infrastructure options, and those decisions can be made at deployment time. Then you get a model where those services can be literally lifted and shifted and made part of an overall application topology. This is very similar to, we are all familiar with the 7 layers of networking, where each layer above a particular layer expects a certain level of services from the underlying layer. This is essentially the same approach, where instead of writing a script or a workflow, you can maintain a set of base virtual machine images, you can create a base set of services, and on top of that, you can create application models or blueprints, assuming that the underlying layers are going to provide the right levels, the right service levels, and the right functionality as desired by the layer above. So very quickly, this is a screenshot of how Clicker does this, and I'm going to dive into more details here. But the idea here is very simple. As you can see on the left-hand side, there's a services palette or a services catalog. You got several tiles there. Those tiles are your building blocks. So there are building blocks around load balancers, app servers, message buses, so forth and so on. And all a user has to do is literally drag and drop the elements that make up their application topology. For example, a load balancer and an app server and a database. Interconnect the topology elements basically capturing the dependencies between the different tiers that make up the application, and then also provide tier-specific, service-specific settings that the application desires. For example, what kind of compute, what kind of storage, what kind of network settings does the load balancer, the app server, and the database need? Once you do that, and because those services are parameterizable, the infrastructure choices have not yet been made, those choices can be now completed at deployment time. At deployment time, you can decide where that database needs to go, what kind of network, what kind of compute does it need, what kind of instances on Amazon as an example. All of those choices get decoupled from the blueprint itself. So if I were to summarize, as opposed to the old approach, which is a script or a workflow-based approach, in this case, all the user has to do is literally drag and drop the elements that make up the application topology, provide any service-specific, application-specific settings, and you're ready to go. What are the benefits? Very simple. If anything changes, your application changes, you need to introduce more elements, more layers, a backend cache, you go back to your blueprint, you redesign it, literally dragging and dropping elements, and rewiring the connections. Because the model is decoupled from the infrastructure choices are flexible. That blueprint is not tied to any particular configuration on an Amazon Web Services, or for that matter of fact, any cloud. And along either dimensions, you can easily make changes. This is an example of one of the blueprints that one of our customers has actually used to deploy their application on an Amazon environment. This is a 5-tier topology. As you can see, it's got 20+ components. It's a mix of load balancers, which in this case is Amazon Web Services ELB. And it's also got a variety of other elements, including an app server and a backend deployer. Through script-based automation and maintaining those scripts, this particular client was actually taking about 3 weeks to get this application up and running on a particular environment on Amazon. And whenever you have to vary that environment, you have to go back and change that script. Once this blueprint was created inside Clicker, they're repeatedly able to launch this deployment, and it just takes about 90 minutes. The other challenge that companies are facing when it comes to application automation, application management on cloud environments, is the trade-off between agility and control. While everybody's seeking more agility, more efficiencies in terms of automating application deployments, often there's a sense, there's a perception that there's lack of control, there's lack of governance around that. What if my developers, what if my engineers can very easily go to an Amazon environment and literally write any script and use any services? Some of those services might actually not be there, meeting organizational compliance or organizational security requirements. How do you actually control that? How do you control what people can do on a particular cloud environment? The interesting thing is that a model-based approach gives you agility, but it also allows you to control what users can do. You can take a very simple permission or ACL-based approach where you can give different permissions to different users for different services, and that limits them to the kind of application models, the kind of application blueprints that they can deploy in a cloud environment. So on the one hand, you get agility, but you're also able to satisfy control, governance, which is critical to enterprise adoption of clouds today. So with that, I would like to end the presentation part and really make this more real by getting into a real demo of Clicker and how Clicker has taken an application-centric approach. Great. So what you're seeing here is the Clicker login portal, and we have a demo account here. I'm going to be logging in as an administrative user here. And very quickly, what you're seeing here is the Clicker dashboard. On the right-hand side are all the clouds that are actually being managed by Clicker. So you see Amazon, different regions of Amazon, East, West, so forth and so on, as well as other public cloud providers, as well as private cloud technologies that Clicker supports. The dashboard is also giving you a current state, which is how many virtual machines am I running on different cloud environments. But also, we are able to give that data by application type. So let's get into the meat of application templates and blueprints. In Clicker, we call them actually application profiles. So here in this demo account, I have a variety of applications that we have pre-modeled, and essentially, these are ready to be deployed. Now, the modeling phase starts with creating an application profile. And this is a very simple WYSIWYG visual designer. And on the left-hand side, there are a variety of application services. So you have load balancers. These include both PaaS services like an Amazon Elastic Load Balancer. And then you also have services that you can directly create on virtual machines running on the cloud environment. So all of these don't have to be PaaS services. And you can create a mix of PaaS-based elements and elements that are going to run on virtual machines on the cloud. Similarly, you have a variety of web server options, message buses, backend caches, databases, so forth and so on. Now, this list of services, there's a set available from Clicker out of the box, so some common open source freeware middlewares are available from Clicker, but this is extensible. So as a user, you can create your own building blocks. Inside a building block, for example, a MySQL database here, essentially you're picking a base operating system image, and then you're defining how that MySQL service needs to be instantiated, installed, started, stopped, so forth and so on. So the same approach can be taken by users here. And for a very simple 3-tier topology, you drag and drop your options. You get your load balancer, you get your app server, and you have your database. The arrows can be used for connecting the different tiers. The arrows basically capture the dependencies between the different tiers of the application topology. So what this tells Clicker is that the app server is dependent on the database and can only be successfully started if the database is up and running correctly. Similarly, the HA proxy load balancer can only be running correctly if the Tomcat app server has started. For each of the elements here, for each of the tiers, on the right-hand side, there is additional information that a user can provide. So you can, for example, if your tier needs to run as a cluster, you can plug in the number of nodes inside a cluster. You can also implement auto-scaling policies. So if you want to scale your cluster between a minimum number of nodes and a max number of nodes, those can be specified. You can also provide options particular to the application. So for example, the Tomcat server would need a WAR file that gets loaded up into the app server, and you can point to that here. And similarly, there are options for hardware requirements. So what is the hardware requirement for my particular tier in terms of minimum CPUs, memory, so forth and so on, as well as firewall rules. There are options where there are areas where users can plug in custom scripts, for example, a node initialization script, as well as service scripts. So it provides a very simple model-based approach where users can drag and drop these different tiers and rapidly, quickly build out an application topology. Nowhere in this topology is the user required to hardwire the application to a particular cloud or within a particular cloud, a particular infrastructure setting. Once you create these blueprints, this can be saved. You can share blueprints with other users. You can also publish them to an application marketplace. And then from here, a user can go ahead and deploy an application. So let me take one of the most classic cloud computing demo applications, WordPress. And I have a WordPress blueprint here. And let me quickly view it to show you how it looks. So it's got an Nginx load balancer. It's got an Apache HTTP server. As you can see in this server, we have set the number of nodes to 2. It also captures the actual WordPress artifact, the WordPress zip file that's going to get loaded into this server. And then similarly on the database side, there are database options, including the database schema setup. This exercise literally takes about 15 minutes for an application like WordPress. Once that's done, a user can go in and hit deploy. You can give your deployment a name. Very interesting feature inside Clicker is you can also assign tags to your deployments, and the tag will automatically select a cloud environment. So here, as you can see, I've assigned a development tag to my deployment, And what that has done behind the scenes is it selected Amazon East as my target cloud environment. On that cloud environment, I can go ahead and now further select my infrastructure options. So I can select my instance type definitions. For example, maybe I want to run my load balancer on an M3 Lodge. I can make similar selections for the other tiers. There are also advanced options around network settings as well as storage requirements. So I'm just going to go with the defaults here and click Submit. And basically what this is doing behind the scenes is it's sending this blueprint for orchestration on an Amazon environment where on the fly, without the need of script-based automation, we are spinning up the right compute instances on Amazon for the database tier, mounting the right storage, EBS in this case, setting up the right security groups between the different tiers, and then also installing the application components, the database, the app server, the load balancer, and then installing the application itself. So this is live right now. It's actually going out to Amazon East, and this does take about a few minutes. It's doing everything from scratch, bringing up the VMs and installing the entire application. So it takes about a few minutes. But I'm on my deployment screen here, and earlier in the day today, actually, I had a WordPress deployment that I launched, and I can go and dive into the details here. So as you can see, this is the deployment view of the application. You see the 3 different tiers up and running. The green dots show that the application is currently live. Each tier is running correctly. And then I can access my WordPress deployment here. So it's actually gone out to the load balancer's public IP address, and this is where my WordPress is running. If the user wants to do any further troubleshooting, they can also look at the entire workflow that was orchestrated behind the scenes. So this is showing the steps for the load balancer. Similarly, you can see the steps for the application server. You'll notice that on the application server side, this was launched as a cluster, so there are actually 2 nodes running there. And if the user wants to go down directly to the infrastructure layer, either through your Amazon console or from Clicker, you can actually launch a browser-based SSH or a VNC terminal to the application itself. So that's the approach that Clicker has taken to cloud management, essentially the ability to create application blueprints. We are seeing similar approaches emerge from the likes of Amazon, like a CloudFormation. And as you look at your cloud strategy, I would encourage you to take a view at this approach and see how it can actually save a lot of work, a lot of time, a lot of effort from traditional script-based automation as your cloud strategy evolves. So with that, I'd like to end my presentation.